This video is for that packet number 6, particle motion, which we've already reviewed just a little bit. Okay, so we are going to start with in that packet number 21, and this is a free response question. And so in this packet they tell you that we have a velocity that's natural log. This is a calculator problem though, but you can actually do some of this without, quite a bit of it. It says that we're just going to look at from 0 to 5. That'll be important here in a second. And then it also says we have a position x equals 8 at time 0. Basically they're saying x of 0 equals 8. This is what we call the initial condition. It's kind of like the plus c if we were to integrate this. Okay, so part A. Part A says find the acceleration at t equals 4. So if we want to find the acceleration at 4, what we really need is just p prime of 4. So we need to take the derivative here and store in 4, and we're going to do that in our calculator. Always when you're doing a new problem, if you think you might have stored variables, make sure you do a quick second F1, clear A to Z, and if you want to clear this screen, you can go F18. You don't really need to clear the memory. Always make sure you're in radians mode. This is auto, function, you're good to go. This is BATT, your batteries are low. So we want to derive that, and if we just wanted to derive it without plugging in for it, we'd go differentiate, and you can use t here if you want. You could use x. Oops, I just cleared that. Here we go. Okay, you're going to close the parentheses, and I didn't do the natural log this time, so make sure you do that at the beginning. Natural log, and then close the parentheses behind the natural log, and then do comma t, close parentheses. Now this alone would just differentiate just that function, but we want to actually plug in 4. So you could retype it in, or you could just do store 4 for t, and we could have done this at the beginning. Make sure you press enter, and you can either select the answer or even just select that. It's going to differentiate and plug in 4 for you, so 5/7. Now, there are no units on this problem, so we're good to move on to part B. So part B, it says find the times t where the particle changes direction. Okay, what we could do is take this velocity and figure out where the velocity is equal to 0. Okay, so to figure out where this velocity is equal to 0, and ultimately we want to know where that velocity is negative. In our calculator, we could do this in the home screen by doing solve. Alright, and because I have something stored for t, I actually really need to clear those if I'm going to do it this way. And you don't have to really go back and retype that thing in. Just type that in. You don't want the d part. You don't want to take derivative here. You want to actually know when velocity is equal to 0. So this is kind of how you can cut and paste. And you want to set this thing equal to not 5, not 50, I mean 0. Right, you still need that comma t. So that's going to give you 1 and 2. So that's the place where that happens. Now, to answer the question part is where is this thing moving to the left? We could do a sign chart. I'm going to show you another way really quick after this. And I started at 0, stopped at 5 because it told me to do that. And what I can do here is say test velocity, and then that'll tell me about the position being left or right. And if you test these numbers, and you're testing back into velocity, not the derivative of velocity, but actual velocity, you end up getting plus, minus, plus. So this particle is moving to the right, then to the left, then to the right. So it says during which intervals is the particle traveling left? We could say it's traveling left on 1 to 2. Okay, a different way we could have done this is to graph velocity. Notice I didn't do t, I used x. And then if we just did a standard 6 window, we don't really need all of this. We really only need 0 to 5. So if we wanted to change that window, we could. It looks like it's a little scrunched there. And when the velocity is positive, the particle is moving to the right. Velocity is negative down here, left, right, and that's happening at 1 and 2, just like how our sign chart told us. So we could have used F5, 0, and then we could have, said, okay, I think it's crossing right here, so lower bound, upper bound. So that's a totally different way we could have found those values and solved that problem. Okay, so to do part C, it says find the position when the time is 2. So basically find x of 2. Okay, now remember, we have an initial condition. We know the particle is already starting at 8. That was that initial condition, so I'm just going to go ahead and use that. All right, and then what I'm going to do is say, well, how far did the particle travel from 0 to 2? Like which is the displacement? And if we integrate velocity, I'm using absolute value bars here, but we don't actually need them. If we integrate instead of derive, we will get the position. Okay, so this right here is going to tell us from 0 to 2, how far did the particle in total move to the right or the left? Okay, and then we're going to add 8 because I said that's where we start. Okay, we're just going to do this in the home screen. So again, we don't really have to type everything in. I'm going to actually go up and grab that derivative. And then I'm going to go back here and change that D part to an integration symbol, which is choice 2. Now, I did open an extra parenthesis that I don't want, so I'm going to subtract that. Also remember that after the T, you need to plug in your bounds. So comma lower bound, comma upper bound. We'll do that after the T and then close the parenthesis at the end. Again, it might give you an exact answer. It might give you a decimal. If you wanted a decimal, you could write it. This would also be fine. Just making sure you know how to do it both ways. Sometimes I think writing the decimal answer is actually easier. So we get 8.369. Alright, so then on to part D. Part D says average speed. Okay, well, if we had an equation for position, we could maybe do this a different way, but since we're given velocity, if this had for just a second said average velocity, you can do this 2 ways. You can do change in position. That would be average rate of change. Or if you wanted to do this as average value, you could do 1 over, oops, that should be a 1. 1 over b minus a, integral a to b of what you're trying to average. Okay, and I'm going to use this one. Okay, so what I want to do here is I want to go 1 over, it wants it on the interval from 0 to 2. And then, again, put this in here. Now, if I were to go ahead and do this just the way it is right now, it would actually give me average velocity. So what do I need to do to change this to speed? This was that 9th point on this problem. That was pretty hard to get. You need to absolute value that. Okay, you're also going to do this type of thing whenever it says total distance traveled. You've got to read into the problems. When it's not caring about direction and it just wants the magnitude, not direction, if you want to think vectors, then this is what you have to do. So I'm going to just kind of tweak what we have here. I don't need the 8 plus here, but I do need the 1/2, so I'm just going to put 0.5 in the front. I need absolute value here, so I'm going to go catalog, ABS, and it is going to open up an extra parenthesis, which you want to close right here before the comma T. And then it'll put it in pretty print for you. And if you put in 0.5, it'll automatically give you the decimal. Okay, I have a squared there, which I don't know what happened with that. Did not want that. So I'm kind of not purposely making these mistakes, but I'm kind of showing you how little things. I am kind of purposely showing you mistakes, but I'm not being real specific about which one I'm making. But I want to show you, look at this. Is it what you wrote down? That had a squared, this didn't. That could be because you're used to doing volume problems. And so then we have 0.371. If you had left off the absolute value bars, you still would have got partial credit here, just not that 9th point. Okay, for both of these, for packet 6, I'm going to encourage you to try to come up with all of these that you can. All right, I do want to mention just something really quick with average acceleration and average velocity. You can do these as a rock or average value. Okay, I will talk about this next week, but I want you to try to look back over and use each other as a resource to write in what you need to write in the rest of this sheet, and we'll fill that thing in as anything that you need. Just ask on Monday.